So in this video, we're going to talk about logarithm properties. So there are many properties of logarithm. One of those is this, where the argument. So we have the 1 is that's what you call the argument, and a is what you call the base of the logarithm. So if the argument of the logarithm is 1, whatever is the base of this logarithm, it's always equal to 0. So for example, if you have a log of 1 to the base 2, then it means it's equal to 0. So as long as the argument is equal to 1, it doesn't matter what is the base, it's always equal to 0. Now the next property that we are going to talk about is when the argument and the base are the same. So log of, for example, a variable a to the base a, which are the same, the argument and the base, it's always equal to 1. Let's say, for example, if we have a number, let's say log of 3, and the base is also 3, it's always 1. Whatever is the number, even if it's log of a million to the base a million as well, then it always equals 1. Another property of logarithm is the product property. So if it says product property because the argument is a product or a result of multiplying two numbers. So for example, we have log of, in general, a variable m times n to the base a. The property is saying that you can expand it in this way, equals log of m to the base a plus log of n to the base a. So it's the same log, the same base, which is a, but it will be separated with the plus sign or an addition. So it means if you have a product argument or a multiplication, m times n, you can expand it and separate it in two different logarithms, log of m plus log of n. But make sure it's the same base, which is a and a. So let's use some specific numbers. Let's say log of 3 times 4, which is actually 12. Let's just put it as 3 times 4 to make it obvious that it's a product to the base 5. So we can separate it into this, log of 3 to the base 5 plus log of 4 to the base 5. So if the given is log of 12 to the base 5, you can separate it as log of 6 to the base 5 plus log of 2 to the base 5, as long as it's a product of the argument. That's 6 times 2, 12 times 1, and here it's 3 times 4. Another property of logarithm is the quotient property. So it says quotient because the argument is it's a result of dividing two numbers. So in this case, we have a log of m divided by n to the base a. So what's the property saying is that you can separate it as a difference, meaning the operation will become subtraction. So it's a separated composed of two different logarithms, log of m to the base a minus log of n to the base a. So you can interchange the two terms. You cannot write log of n first minus log of m. Whichever is the numerator, in this case, m is the numerator in the fraction, then that means it's the first one to write, log of m to the base a, and then minus, which is the denominator, which is n, log of n to the base a. Now let's use some specific numbers. Let's say, for example, log of 5. So we're going to write 5 as 10 divided by 2 to make it obvious that it's a result of dividing two numbers. Log of 10 over 2 to the base 4. So to expand it, according to the properties of logarithm, the quotient property, so we can expand it as log of 10 to the base 4 minus log of 2 to the base 4. Another property of logarithm is the power property. So that means if it has an exponent, like for example here, in general, it's log of m to the power of n to the base a. So we can write it as, so you copy first log of m to the base a. So now where's the exponent? We can write it at the left side. So it becomes a multiplier of the logarithm. So you can write it as n, which is the exponent, times log of m to the base a. So it becomes a multiplier from an exponent. So you can do that according to the properties of the logarithm. So using a specific number, let's say log of 2 cubed, or log of 2 to the power of 3 to the base 5, you can write it as log of 2 to the base 5 and multiply it by 3. So 3 times log of 2 to the base 5, which is the same as log of 2 cubed to the base 5, according to its property. Now another property of logarithm is you have a log of a to the base b. You can change its form by using another base, and the base will become an argument. So what does it mean by that? Log of a to the base b. Observe that the a is the argument, base is the b. Now you can write it in this way: log of a to the base c. So I change the base into c and put a denominator, log of b to the base c. So the base is changed, and observe that the base b is now becomes an argument in the denominator. So you can write it in that way. So you can use any new base as long as it's the same bases on top and at the bottom. So log of a to the base b can be written as log of a to the base c, like it's like any just random numbers that you're gonna use as the base, and log of b, which was the base in the previous form, to the base c, which is c is the new base. Let's use some specific number, like for example, log of 6 to the base 3. So you can write it as a log of 6 to the base 10, or you can use any number, log of 6 to the base 5, any number as the base, a new base, and log of 3, which was the previously the base, and now it becomes an argument. So log of 3 to the base 10, as long as it's the same base on top and at the bottom. But you can use any kind of base as long as it's the same base. So they are equal to log of 6 to the base 3. Another property of logarithm is if it's like this. It's an equation. Log of a to the base b is equal to log of c to the base b. So what does it mean by this? They are having the same base, just different argument. So if it's like this, it means, or it implies, that the a is equal to c. So like for example, if we have log of x to the base 5 equals log of 3 to the base 5. So if it's having the same base, then you can equate the two arguments as x equals 3. So you can use this property in solving equations that involves logarithms. Now another property of logarithm is if it's in this form where it's an exponential form with a logarithm as the exponent. So a to the power of the log of x to the base a. Now this is applicable only if the bases are the same. The a and the a on the logarithm are the same. So if it's like this, then this is just simply equal to x, or the argument of the logarithm. So if we're going to use some specific numbers, let's say for example 4 log of 5 to the base 4, then it's just simply equal to 5. Now again, it's only true when the bases are the same, like the base 4 and the base of the logarithm, which is also 4, are the same. Then it's equal to the argument of the logarithm. So if it's not the same basis, then it is not applicable. Now another property of logarithm is if the argument and the base are both having an exponent. Let's say log of a to the base, to the power of m to the base b to the power of n. So they both have exponents, m and n. So we can write it in this way. So log of a to the base b, so just simply remove the exponents and use it as a multiplier, but write it in fraction form, m over n. So the top is the exponent of the argument, and the bottom or the denominator is the exponent of the base. You cannot interchange that. So log of a to the base b times m over n. So let's use some specific numbers, like log of 4 to the power 5 over 2 cubed. So you can write it as a log of 4 to the base 2, and then write the exponents 5 over 3. Now, one last property of logarithm is if it's a negative of a logarithm, negative log of a to the base b. So there is a way to change its form so that you will avoid a negative sign. So you can write it in this way. So log of 1 over a to the base b. So just simply take the reciprocal of the argument. Or another way is to write the base to its reciprocal and retain the argument. So you can just choose either of the two. Either the argument, I'm going to take the reciprocal. If you say reciprocal, you reverse the numerator and the denominator. Or you can do it in the base. You just choose either of the two. You cannot do simultaneously both the argument and the base. Just choose either of the base and the argument to reciprocate. Now let's use some specific numbers. Let's say a negative log of 9 to the base 5. So you can write it as log of 1/9 to the base 5, or you can choose the base to take its reciprocal. So log of 9 to the base of 1/5.